Welcome to Module 2 of our course on prompt engineering. Today we're moving from the foundational concepts we explored in Module 1 to practical, hands-on techniques that will transform how you communicate with AI systems. Think of this module as your tactical toolkit, the specific methods that bridge understanding with application, while Module 1 explained the why behind effective prompt engineering. Module 2 focuses on the how-specific techniques you can implement immediately to achieve consistent, high-quality results. Whether you're using AI for content creation, data analysis, technical work, or creative projects, these essential techniques will significantly enhance your outcomes. Let's begin building your prompt engineering toolkit for maximum impact. Before diving into today's content, let's situate Module 2 within our broader learning journey. Having completed Module 1, you now understand the fundamental concepts and mindset required for effective AI communication. Today's session builds directly on that foundation, introducing specific techniques that apply those concepts in practical contexts. This step-by-step progression is intentional for moving from understanding to application. In subsequent modules, we'll advance to more sophisticated approaches, workflow integration, and ethical considerations. But today's essential techniques form the bridge between conceptual knowledge and practical mastery. The skills you'll develop in Module 2 create the foundation for everything that follows. So let's make sure we establish these techniques thoroughly. By the end of this module, you'll master 7 specific capabilities that directly enhance your AI interactions. You'll learn to construct well-structured prompts using 4 essential components that guide AI systems effectively. You'll implement role assignment techniques that access specialized knowledge and create consistency in AI responses. You'll control output formatting to ensure information is presented exactly as needed for your purpose. You'll apply example-driven prompting to demonstrate patterns when explicit instructions aren't sufficient. You'll customize templates for recurring tasks, saving time while maintaining quality. You'll develop systematic testing and refinement methods. And finally, you'll be able to evaluate different techniques for specific scenarios. These practical skills will immediately improve your results across diverse applications. Why dedicate time to learning these techniques? The impact is substantial. Our research with professionals across industries shows structured prompt engineering saves an average of 17 minutes per complex AI task. That's nearly 3 hours saved weekly for someone who performs 10 such tasks. Beyond time efficiency, these techniques eliminate what we call the prompt lottery, that frustrating inconsistency where sometimes you get brilliant results and other times unusable outputs from similar requests. Structured approaches also reduce cognitive load, freeing your mental energy for your primary work rather than crafting elaborate prompts. Perhaps most importantly, these skills apply across domains from marketing to development to education, making them valuable regardless of your specific profession. As AI becomes increasingly central to workflows, these techniques create significant professional advantage. Let's examine what makes prompts truly effective. We're moving beyond basic requests to structured communications built on 4 crucial pillars. Clarity ensures your instructions are unambiguous and easily understood. Specificity provides detailed guidance about exactly what you're seeking. Context offers the background information that frames your request appropriately. And constraints establish boundaries that shape the response. Together, these pillars create a framework that AI can process effectively. Think of this as similar to effective human communication. When you provide clear instructions with appropriate context and specific parameters to a colleague, you're much more likely to receive the results you want. The same principle applies to AI, but with even greater importance due to the literal way AI systems process information. Every effective prompt can be broken down into 4 structural components that work together to guide the AI. The instruction element forms the core request, the specific task you want the AI to perform, such as analyze, summarize, or create. The content element provides the information the AI should work with, like a text passage, dataset, or topic. The context element supplies background that informs how the AI should approach the task, including purpose, audience, or relevant constraints. And the output element specifies how the response should be formatted or structured. When crafting prompts, consciously incorporating each of these elements provides the AI with a comprehensive framework that significantly improves relevance and usefulness. Not every prompt requires extensive detail in each component, but considering all four ensures nothing critical is omitted. Let's examine how these components look in practice with a concrete example. This prompt demonstrates all four components clearly delineated. Context establishes the perspective of a marketing specialist focused on eco-friendly products. Instruction specifies the task, creating a product description. Content provides the specific subject, a reusable bamboo coffee cup with specific features, and output defines constraints for the response. 100 words with emphasis on sustainability and persuasive language. Notice how each component contributes essential information that shapes the final result. The explicit structure eliminates ambiguity and gives the AI clear parameters. Compare this to a simple request like write about a coffee cup, which would require the AI to make numerous assumptions about what you actually want. Structured prompts eliminate these assumptions, leading to more targeted responses. There's no single correct way to structure prompts. Several effective patterns exist that you can adapt based on your needs. The sequential pattern follows a logical flow from context through instruction and content to output, which mirrors natural communication. The task-first pattern leads with instruction for immediate clarity, particularly useful for straightforward requests. Bracketed sections use explicit delimiters like context or instruction to clearly separate components, which helps with complex prompts. And the paragraph style integrates components into natural language for a more conversational approach. Each pattern has advantages in different situations. For instance, bracketed sections excel for complex requests, while paragraph style may feel more natural for creative tasks. Experiment with these patterns to discover which works best for your specific applications. Our next technique, role assignment, is extraordinarily powerful yet often overlooked. By instructing the AI to adopt a specific role or persona, you fundamentally alter how it processes and responds to your prompts. This technique activates specialized knowledge domains within the AI system, creating consistency in tone, vocabulary, and perspective. Think of it as providing a lens through which the AI processes information. A financial analyst sees different aspects of a situation than a marketing specialist or a teacher would. Role assignments set parameters for expertise level and communication style, allowing you to access different knowledge frameworks. This approach is particularly valuable when you need specialized expertise or consistent perspective across multiple prompts on related topics. Let's explore 4 primary types of role assignments, each serving different purposes. The expert role positions the AI as a subject matter specialist. As an experienced cybersecurity professional, analyze these vulnerabilities. This activates domain-specific knowledge and analytical approaches. The audience-specific communicator directs the AI to target a particular audience, explain quantum computing as if teaching high school students. This shapes language complexity and examples appropriately. The process role assigns a functional task that implies a process. Act as an editor reviewing this text for clarity. This focuses on specific analytical or creative methods. And comparative roles request multiple perspectives. First as an advocate for, and then as a critic against. This generates balanced viewpoints. Each role type shapes how the AI approaches your request. To implement role assignments effectively, follow these best practices. First, be specific about expertise level and specialization. As a cardiologist with 15 years of clinical experience, provides more guidance than simply as a doctor. Combine roles with tone and style instructions when needed as a financial analyst writing for a non-technical audience. Consider which perspective best aligns with your desired outcome. Sometimes a non-expert role actually produces more accessible explanations. Use role assignments strategically. Not every prompt requires one, particularly for simple factual questions. And experiment with different roles for the same content to see how perspective shifts the response. The right role assignment can dramatically improve relevance and focus, especially for specialized topics where domain knowledge significantly impacts the quality of analysis. Let's compare basic and improved role assignments to see this technique in action. The basic prompt as a doctor, explain headaches, provides minimal guidance about expertise, focus, or depth. The improved version specifies as a neurologist with 15 years of clinical experience, explain the different types of headaches, their likely causes, and when a patient should seek medical attention. Note the key differences: a specialized medical field rather than general medicine, defined experience level indicating expertise, and specific aspects to address types, causes, when to seek care. These enhancements guide the AI to provide information from a more precise perspective with appropriate depth and focus. The same approach applies across domains. Specificity in role assignment consistently produces more targeted, useful responses. Our third essential technique focuses on controlling how information is presented. Without specific formatting instructions, AI systems typically default to narrative paragraphs that may not effectively highlight key information or match your intended use. Output formatting controls ensure information is presented in the most useful structure for your specific purpose. This makes responses immediately applicable to your needs, whether you need a comparison table for decision-making, a bulleted list for quick reference, or JSON data for software applications. Proper formatting improves information processing and retention while creating consistency across multiple AI interactions. This technique is particularly valuable when integrating AI outputs into workflows, documents, or presentations where specific formats are required. AI systems can generate responses in a wide variety of formats to suit different needs. Structured data formats include tables for comparative information, bulleted or numbered lists for sequential steps, JSON or CSV for machine-readable data, and hierarchical outlines for organized concepts. Creative formats include stories and narratives, dialogues between characters, scripts for videos or presentations, and various creative writing forms like poems or songs. Analytical formats include reports with executive summaries, evaluations using specific frameworks, comparative analyses with pros/cons, and annotated research summaries. You can also specify visual structure through sections, headings, and emphasis, or request technical formats like code blocks and algorithms. Each format optimizes information presentation for specific purposes. Let's explore several techniques for implementing format controls in your prompts. Explicit format requests directly state the desired structure. Format your response as a 3-column table with headings. Markup indicators specify formatting language. Use Markdown to format your response with headings and bullet points. Visual structure guidance demonstrates the desired layout. Present information in this layout. Example layout. Length control sets boundaries. Provide a response in approximately 200 words. And sequence specification determines information order, present chronologically, or order from most to least important. These techniques can be combined as needed. For instance, requesting a Markdown formatted table with specific column headings and a 150-word summary beneath it. Clear format instructions eliminate the need to reformat AI outputs, saving time and ensuring information is immediately usable. Let's contrast basic and improved format control examples. The basic prompt, "Tell me about project management methodologies," would likely produce several paragraphs of narrative text discussing various approaches, leaving you to mentally compare their features. The improved version requests, "Compare Agile, Waterfall, and Lean project management methodologies in a table with rows for each methodology and columns for key principles, best applications, limitations, and required tools." This structured request produces a comparative table where differences are immediately visible. The format dramatically changes how you process the information. Narrative text requires sequential reading and mental comparison, while a table enables instant visual comparison across specific dimensions. This simple formatting technique transforms the same information into a significantly more useful resource. Our fourth technique, driven prompting or few-shot learning, is particularly powerful for tasks with subtle patterns or specific formats. Rather than relying solely on explicit instructions, this approach demonstrates patterns through concrete examples showing rather than telling the AI what you want. This method is especially effective when patterns are difficult to describe concisely or when you need outputs that follow specific stylistic conventions. By providing input-output pairs, you create a clear model of the expected transformation or pattern. This reduces misinterpretation of complex instructions and helps the AI understand nuanced requirements. Think of it as similar to how we often teach humans. Demonstrating a process is frequently more effective than explaining it abstractly. Several approaches to few-shot learning can be employed depending on your needs. Standard few-shot provides multiple input-output pairs to establish a pattern, like classification examples or writing samples. Chain of thought includes intermediate reasoning steps between input and output, demonstrating not just the answer but how to reach it, particularly valuable for complex reasoning tasks. Self-consistency demonstrates consistency across different scenarios, ensuring the same principles are applied throughout. Contrast examples show both correct and incorrect responses, highlighting what to avoid. And progressive complexity orders examples from simple to complex, building understanding gradually. Each approach has specific strengths. Standard few-shot works well for straightforward patterns, while chain of thought excels for tasks requiring multi-step reasoning or detailed explanation. Creating effective examples requires strategic consideration. Ensure diversity while maintaining pattern clarity. Examples should vary enough to demonstrate the pattern applies broadly, but not so much that the pattern becomes unclear. When possible, order examples from simple to complex, allowing the AI to build understanding progressively. Include edge cases relevant to your task, especially if you expect to encounter unusual situations in real applications. Most applications need only 2 to 4 examples, enough to establish the pattern without excessive length. And make examples representative of actual expected inputs. Artificial examples may establish patterns that don't transfer well to your real-world cases. Well-crafted examples can communicate subtle expectations more effectively than lengthy explanations, so invest time in creating representative, clear examples. Here's a concrete example of few-shot learning applied to sentiment classification. Rather than explaining the abstract concepts of positive, negative, and neutral sentiment, this prompt demonstrates the classification through examples. Notice how it provides 3 diverse examples that establish clear patterns. Enthusiastic language with exclamation points indicates positive sentiment. Balanced language with qualifiers suggests neutral sentiment, and critical language with negative descriptors signals negative sentiment. The AI can then apply these patterns to the final unlabeled review. This approach is far more effective than trying to explain all the nuances of sentiment detection in abstract terms. The examples efficiently communicate both the task and the classification criteria, allowing the AI to inductively learn the pattern rather than following explicit rules. Our 5th technique introduces prompt templates, standardized structures for recurring AI tasks. Templates save significant time by providing proven starting points rather than crafting prompts from scratch for each interaction. They ensure consistency across similar tasks, reducing variability in outputs. Templates incorporate best practices refined through testing, benefiting from collective experience. They dramatically reduce the trial and error typically involved in prompt design. Think of templates as similar to document templates in word processing. They provide structure and formatting so you can focus on content rather than recreating the framework each time. Templates are particularly valuable for frequent tasks like content creation, analysis, explanations, or decision support, where a consistent approach yields reliable results across multiple applications. Prompt templates can be organized into categories based on their purpose and structure. Content creation templates include frameworks for blog posts, social media content, product descriptions, and marketing copy. Analysis templates provide structures for SWOT analyses, evaluations, comparisons, and data interpretation. Learning and explanation templates offer frameworks for concept explanations, tutorials, study materials, and simplified explanations. Decision support templates include structures for pros-cons lists, evaluation matrices, research summaries, and recommendation frameworks. Technical templates provide frameworks for code review, documentation, debugging, and algorithm explanation. By identifying which category best matches your needs, you can select appropriate templates to adapt rather than starting from scratch. This categorization helps organize your template library for easy reference. Templates provide starting points, but customization makes them truly effective for your specific needs. Follow this 6-step process to adapt templates successfully. First, identify the core structure that works for your task category, whether that's comparison, explanation, analysis, etc. Then adjust the role, context, and constraints to fit your particular requirements. This personalization makes generic templates specific to your situation. Calibrate the level of detail based on task complexity. More complex tasks typically require more detailed templates. Add relevant examples when needed, especially for tasks with subtle patterns. Test the customized template and refine based on results. Templates often require tweaking to optimize for specific applications. Finally, save successful templates for future use, building a personal library of proven approaches that work for your recurring needs. Let's examine a specific template example for comparative analysis. This template provides a comprehensive framework for comparing multiple items, concepts, or approaches. The role element establishes relevant expertise in the subject area. The task element clearly defines what items should be compared. The criteria element specifies the dimensions for evaluation, and the format element details exactly how the information should be presented. In this case, a table with items as rows and criteria as columns, followed by a summary with recommendations. Notice the template uses placeholders and curly braces like subject area and list items that you would replace with specifics for your situation. This template creates a consistent structure while allowing customization for numerous comparative analysis scenarios, from product evaluations to strategy comparisons. Mastering prompt engineering techniques requires practice. The concepts make sense intellectually, but skill development comes through application. That's why hands-on activities form a critical part of this module. These structured exercises allow you to apply techniques to realistic scenarios, receiving immediate feedback on effectiveness. Just as you wouldn't expect to master a musical instrument by reading about it, prompt engineering requires deliberate practice to develop proficiency. Through these activities, you'll build muscle memory for constructing effective prompts and develop intuition for which techniques work best in different situations. The feedback loop of designing, testing, analyzing, and refining prompts is essential for skill development. Each activity is designed to strengthen specific aspects of prompt engineering while building your overall understanding of AI interaction patterns. Let's explore 5 core practice activities that develop essential skills. Component analysis involves identifying missing elements in basic prompts like write about climate change and reconstructing them with all essential components. Role assignment workshop has you create different prompts using varied expert roles for the same complex topic, evaluating how each affects output quality. Format control exercise asks you to request the same content in different formats: bullets, tables, narratives, to evaluate which most effectively communicates information. Few-shot learning application focuses on creating examples for pattern-based tasks, experimenting with number, order, and complexity of examples, and template customization involves adapting a standard template for your specific needs, testing, and refining based on results. These activities build complementary skills that together form comprehensive prompt engineering proficiency. Moving beyond isolated techniques, our workshop section connects these skills to authentic use cases across domains. In business applications, you'll craft prompts for competitive analyses, marketing strategies, financial projections, and business proposals. For educational contexts, you'll develop prompts for personalized learning materials, lesson plans, assessments, and explanations tailored to student needs. Content creation applications include content calendars, articles in specific tones, social media campaigns, and scripts. Technical scenarios cover code optimization, documentation, database design, and testing protocols. Regardless of domain, you'll follow a consistent process, design a prompt applying appropriate techniques, test it with AI systems, refine based on results, share for peer feedback, and document effective patterns for future reference. This structured process builds transferable skills applicable across professional contexts. As you practice these techniques, you'll discover patterns that consistently produce excellent results for your specific needs. Systematically documenting these successful prompt patterns creates an invaluable personal resource. Organize your library by task type and application area for easy reference, whether that's marketing content, data analysis, or technical documentation. Include annotations on effectiveness and limitations to guide future use. This creates a growing database of proven approaches you can draw upon rather than reinventing solutions each time. Think of this as your personal cookbook of prompt recipes that you know work well. Your library becomes more valuable over time as you continue refining based on real-world results. This cumulative approach accelerates your productivity and ensures consistent quality across all your AI interactions. Let's examine the concrete impact of these techniques based on our research with professionals across industries. Users report 50 to 70% reduction in prompt iteration time. What once required multiple attempts can now be achieved in 1 or 2 tries. Template-based approaches achieve an 80% first attempt success rate, dramatically improving efficiency. Teams using standardized prompt libraries report consistent outputs regardless of which team member is interfacing with AI systems. These techniques work across different AI models with minor adjustments, creating transferable skills as the technology landscape evolves. Perhaps most importantly, expertise becomes encoded in shareable prompt libraries, allowing organizations to capture and distribute best practices. These metrics demonstrate that systematic prompt engineering isn't just theoretically sound, it delivers measurable performance improvements in real-world applications. As we conclude Module 2, let's reinforce 6 key principles that form the foundation of effective prompt engineering. Structured components create clarity that directly improves AI responses. Role assignment accesses specialized knowledge domains that enhance relevance and focus. Format controls ensure information is presented in the most useful way for your specific needs. Examples communicate patterns efficiently, particularly for subtle or complex expectations. Templates accelerate consistency and implementation across similar tasks. An iteration drives continuous improvement through systematic testing and refinement. In our next module on advanced prompt engineering techniques, we'll build on these essential skills to explore sophisticated approaches for complex scenarios, including chain of thought prompting, advanced persona creation, and strategies for managing context limitations. The techniques you've learned today provide the foundation for these advanced applications.